Science Olympiad, Class 9. Matter in our surroundings.
Introduction. The air we breathe, the food we eat, stones, clouds, stars, plants and animals, even a small drop of water or an animal, even a small drop of water or particle of sand, everything is matter. We can also see as we look around that all the things mentioned above occupy space and have mass. In other words, they have both mass and volume. In this chapter, we shall learn about matter based on its physical properties. Nature of matter. Take 2-3 crystals of potassium permanganate and dissolve them in 100 ml of water. Take out approximately 10 ml of this solution and put it into 90 ml of clear water. Take out 10 ml of this solution and put it into another 90 ml of clear water. Keep diluting the solution like this 5 to 8 times. Is the water still colored? This experiment shows that just a few crystals of potassium permanganate can color a large volume of water, say about 1000 liters. So, we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keep on dividing themselves into smaller and smaller particles. Matter has space. Place a perfume bottle in a corner of your class. How close do you have to go near it so as to get its smell? Now, open the bottle. What happens? Do you get the smell sitting at a distance? Yes, you get the smell emanating from the perfume bottle. Record your observations. Particles of matter attract each other. Take an iron nail, coal piece, a piece of thick aluminium wire and a pencil lead. Try breaking them by hammering, cutting or stretching. In which of the above 3 substances do you think the particles are held together with greater force? The above activity suggests that particles of matter have force acting between them. This force keeps the particles together.
Conclusion. Particles in matter attract each other. The force with which they attract each other varies from matter to matter. In some kinds of matter, waste paper, matchstick, the force is small, as we can tear or break them easily. In other kinds of matter, iron nail, the force is large, as we cannot break the nail easily. The particles of matter show 3 types of motion. Translatory motion, when particles move in straight lines, changing direction without loss of energy on colliding with another particle or the wall of the container. The motion is called translatory motion. Translatory motion is maximum in gases and the least in solids when compared to liquids. Rotational motion, when particles move around their own axis, the motion is called rotational motion. This motion is similar to the rotation of Earth around its axis. Rotational motion will be high in gases and in liquids. Vibrational motion, when particles have a to and fro motion about a mean position, the motion is called vibrational motion. This motion is maximum in solids, as the particles are held in a rigid structure. Cohesive force of attraction is present between the particles of the same kind. For example, this force of attraction is very strong between the particles in the nail. Due to this, the nail cannot be broken into 2 easily. The force of attraction is weak between the particles in the waste paper and matchstick. Due to this, the waste paper can be torn easily and the matchstick is broken easily. Adhesive force of attraction is present between the particles of different kind. For example, the particles of water have adhesive force of attraction with the glass container. Some drops of water can therefore be found sticking to the walls of the container. Based on physical state, matter can be classified into solids, liquids and gases.
States of matter. Solid state. Solids have a tendency to maintain their shape when subjected to outside force. Solids may break under force, but it is difficult to change their shape, so they are rigid. Liquid state. Liquids have no fixed shape but have a fixed volume. They take up the shape of the container in which they are kept. Liquids flow and change shape, so they are not rigid but can be called fluid. Gaseous state. In the gaseous state, the particles move about randomly at high speed. Due to this random movement, the particles hit each other and also the walls of the container. The pressure exerted by the gas is because of this force exerted by gas particles per unit area on the walls of the container.
Kinetic theory of matter. According to the kinetic theory of matter, matter consists of very small particles. These particles can be atoms, molecules, or ions. The particles are in state of constant and random motion. They have kinetic and potential energy. The particles attract each other with a certain force of attraction. The particles present in a solid, liquid, and gas differ as follows. The solid state and the kinetic theory of matter. In solids, the particles are very close together. Due to this close arrangement, a solid has a definite volume and a definite shape. The particles occupy very little space, and hence solids have high density. As the particles are close, the forces of attraction between them are high. The referred solids have high melting points. They have maximum vibratory motion oscillating about a mean position. The liquid state and the kinetic theory of matter. The interparticle distances are larger than in a solid. The particles can flow within a certain boundary. They have a definite volume. The liquid has no definite shape, as the particles can be piled up or spread out within the surface for the liquid depending on the shape of the container. As the particles are not so close as in solids, the forces of attraction between these are lower than in solids. The particles in a liquid move in all directions, changing direction whenever they collide with other particles, but without loss of energy. The gaseous state and kinetic theory of matter. In gases, the particles are very far apart. Due to this, a gas does not have a definite volume and a definite shape. The particles occupy all the space available to them, and hence gases have low density. As the particles are far apart, the forces of attraction between them are the least. The particles in a gas move in all possible directions, colliding with other gas particles and with the walls of the container. There is no loss of energy on collision, only a change of direction of motion. The collisions with the walls of the container of the gas is responsible for the pressure exerted by the gas.
Effect of change of temperature. Take some camphor or ammonium chloride, crush it and put it in a china dish. Put an inverted funnel over the china dish. Put a cotton plug on the stem of the funnel as shown in figure. Now heat slowly and observe a change of state directly from solid to gas without changing into liquid state or vice versa is called sublimation. Evaporation. Particles of matter are always moving and are never at rest. At a given temperature in any gas, liquid or solid, there are particles with different amounts of kinetic energy. In the case of liquids, a small fraction of particles at the surface, having higher kinetic energy, is able to break away from the forces of attraction of their particles and gets converted into vapor. This phenomenon of change of a liquid into vapor at any temperature below its boiling point is called evaporation. Evaporation. Water is evaporating continuously from the surface of seas, rivers, lakes, oceans, and from the green plants on land to the atmosphere due to the heat of the sun. The water vapor rises up. The air higher up in the atmosphere is cooler. This air cools the water vapor and it condenses to form small drops of water on dust particles forming clouds. As the clouds cool down, these water drops become bigger and fall down as rain. Rainwater enters the seas, rivers, lakes, ponds and streams and evaporates again.
An interesting conclusion. If a solid has a low melting point, then the attractive forces between the particles are weaker when compared to a solid that has higher melting point. When matter is cooled, the reverse happens. In gases, as the temperature falls, the random motion of the particles decreases. The attractive forces increase and the gas becomes liquid. On further cooling, the liquid particles' motion decreases further. The particles come closer together and attractive forces increase to such an extent that the liquid becomes a liquid. Latent heat or hidden heat. Latent heat of vaporization of water is the amount of heat required to change 1 gram of water at 100 degrees Celsius to 1 gram of steam at 0 degrees Celsius. Its value is 2260 joules per gram. Explanation. Consider water at 100 degrees Celsius. On further heating, it changes to steam at 100 degrees Celsius. Water at 100 degrees Celsius requires some extra heat called latent heat of vaporization to convert to steam at 100 degrees Celsius. It is important to note that water at 100 degrees Celsius absorbs some heat without undergoing any change of temperature to change to steam at 100 degrees Celsius. Any substance will show an increase in temperature if it absorbs heat, but at the boiling point of the substance, heat is absorbed without increase in temperature. The heat that is absorbed at the boiling point is used to break the molecules free so that the liquid gets converted to a gas. This is the reason why the heat absorbed without change in temperature is called latent heat. Application. Steam boils are more severe than boiling water boils, as a considerable amount of heat is used for condensation of the steam to water when it is exposed to the skin. Latent heat of solidification of water is the amount of heat liberated by 1 gram of water at 0 degrees Celsius to form 1 gram of ice at 0 degrees Celsius. Its value is 336 joules per gram. Explanation. Consider ice at 0 degrees Celsius. On further heating, it converts first to water at 0 degrees Celsius before its temperature starts rising again. This takes place by absorbing some extra heat. The extra heat is used to break the molecules free so that the molecules can become liquids. This heat is called latent heat of solidification. Application. It is partly due to the high latent heat of solidification that lakes do not freeze suddenly. The changes of physical state with change in temperature can be represented as follows. Interconversion of matter. Changing temperature, pressure, or both can change matter from one physical state to another. Changing a solid to a liquid is called melting. On heating a solid, the particles acquire kinetic energy and overcome the attractive forces to start moving like in a liquid. Thus, a solid is said to melt and become a liquid on heating. Changing a liquid to solid is called solidification. On cooling a liquid, the kinetic energy of the particles decreases and the attractive forces become stronger. The particles come closer like in a solid. Thus, a liquid is said to solidify and become a solid on cooling. Changing a liquid to gas is called vaporization. On heating a liquid, the kinetic energy of the particles increases and the attractive forces become still weaker. The particles break free from the surface of the liquid. Thus, a liquid is said to vaporize and become a gas. Changing a gas to liquid is called condensation. On cooling a gas, the kinetic energy of the particles decreases and the attractive forces become dominant. The particles come close together like in a liquid. Thus, a gas is said to condense and become a liquid. Changing a solid to gas directly is called sublimation. On heating certain solids, the kinetic energy of the particles increases so much that the attractive forces become very, very weak. The particles break free from each other in the solid and start moving like in a gas. Thus, a solid is said to sublime to become a gas.